Hi everyone. So in this quick video, there already is one recorded by the same person that you watched the lesson from for the first two rows. So that's already linked in the plan. Melissa Maribel gives you a solution, a verbal solution version for calcium and nickel. I'm going to give you even more support if you want even more for aluminum, nitrogen, and neon. All right, if you don't think you need this support, feel free to just go check the answer key that is attached right below this link in the answer key. By the time you see that, these three will be filled out as well. If you struggle and you want to come back to this video, it is always here for you. All right, so neon. I have also pre-filled out the number of electrons because that's level 3 info, but really quick, I know that neon in a neutral atom has 10 electrons because the atomic number is 10. Atomic number always equals proton number, 10 in this case. And because it's neutral, my electrons must be equal to protons in order to cancel out positive charges in the protons with the negative charges of the electrons. So neon has 10 electrons, nitrogen 7, aluminum 13 in a neutral version of that atom. The next step is to find them on the periodic table. Neon is right there if you're looking down here. All right, that's neon. So we read this like we would a book, going from left to right, top to bottom, and assign electrons as we go. Each one of these little three-parters is, I think of as like a zip code. How close is it to the nucleus? That's the first large number. What is the shape of the zone that we would expect to find the electron in? S, P, D, or F. And how many electrons are this distance from the nucleus in this shape of probable location? And you have your three-parter. I number my periodic table so we can see the shell or energy level here, 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 and here. And that'll determine the large number that comes first. And you count starting from hydrogen, and you stop when you get to the target cell, as long as it is neutral. So we go 1s, 1, 2. 1s, 2. Continue counting. We get 2s, 1, 2. Continue counting. We have 2p, 1, 2, 3, 4, 5, 6. 2p6, that got us to our target cell. We are done. Neon is a noble gas, so it does not have a shortcut. So I did not put the condensed electron configuration there. Next up is nitrogen. I'm going to erase my little scribbles from my chart over here. And I'm going to find nitrogen on there. Nitrogen is going to be right here if you look at a larger version of this. And what do we have? We have, actually, I'm going to try coloring that differently. All right. We have 1s, 1, 2. 1s, 2. Then 2s, 1, 2. 2s, 2. Then we have 2p, 1, 2, 3. 2p, 3. We don't say 2p6 because we had to stop here. Nitrogen has 3 less electrons than neon, so you can see the first 2 electrons, they went in the same place, whether they're neon or nitrogen. The next 2 electrons went into the same location around the nucleus. The next 3 went into the same place, but with neon having 3 more, it was able to fit 3 more electrons into that same distance from the nucleus and the same shape, the P shape. Shortcut here, it's not really much of a shortcut, but the last noble gas was helium. So you put helium in brackets and say from there on out you had 2s2, 2p3. So 2s2, 2p3. Aluminum has 3 more electrons than neon, 6 more than nitrogen. So it's going to start the same way. If we find it on the periodic table, aluminium is right there on the little periodic table down below. So if we count it out, we have 1s2, 2s2, 2p6, 3s2, 3p1. So 1s2, 2s2, 2p6, 3s2, 3p1. If we are to write that in shortcut, the closest noble gas that is smaller is right here, and that, if you see a real periodic table, is neon. So I'll put neon in brackets, and I will only show the address of the electrons that came after neon. So that is 3s2, 3p1. Or if you do it from here, find your noble gas, neon, 3s2, 3p1. All right. There are 3 more that did not get a verbal explanation. If you would like more time to solve these, think about them with me, come chat. Talk to me, talk to your peers. This is not an easy topic. It is not intuitive, but once you get the hang of it, it's something that sticks with you. So keep practicing and advocate for one-on-one support during our Zoom meetings. If I can help you in any way, get the hang of this and find the trick. All right.